think many people are joining still. Okay, so let's go on the book. So we will be studying first the bisection method and then several other methods, and we will be doing some questions on that. Okay, I think it's already discussed in your tutorial in the lectures, is it? If not, then let's discuss that. Okay, if you can see my cursor here. So to determine a root of, okay, I don't understand. Okay, yes, so just see my cursor point. So an algorithm for halving the interval is like bisection method. So if you have a root, you have to find the root of equation fx equals 0. And how do you find that? So how are you gonna start with? What happened? Yes, sorry. Just go. I just go with this one. It's my first time teaching. My iPad is not with me. Sorry. But it's a very easy and useful method anyways. Okay. So you're gonna start with the root f of x equals 0. Can you see my cursor? Is it visible, everyone? Okay, I just admit some people in. Wait. I think people are coming late. I have to admit it's time. Just come on time. Yes. So yes, so if you have a complicated function f and you have to solve like equation f of x equals 0, then the first common method to do that is just to use the bisection method. The name implies bisection. It means having it to bi means you need to reduce the interval into half and then do the same process. So if you have some points like x1 and x2, so you start with any random values x1 and x2 and just set x3 equals to x1 plus x2 by 2. It's kind of an average of two values. And if that happens, if f of x3 times f of x1 is less than 0, then you set x2 equal as x3. It means that if x1 and x3 has kind of opposite signs, that's why the product is less than 0, right? So if x1 and x3 has opposite signs, the function value at both these points has opposite sign, then you say that x2 is x3, and otherwise you set x1 is x3, and you end this until you reach certain kind of tolerance value between x1 and x2, like the difference. So you are kind of reaching to 0, right? You're yeah, just, and so there are several methods of providing this tolerance value, but you can use this one. And there is also like mod fx3 is less than something you can describe. So I just gonna write here and you have to see this. All right. Yes, so I just use maybe different color, black one. Okay, so it is showing the black. So this is the bisection method. I hope the screen is visible. So you start with, suppose you have a complicated function f of x equals 0 that I have already described. You start with some random values x1 and x2 and find the average of between two, which is just x3, which is just x1 plus x2 by 2, right? Oh, why is that? Okay, and then you just calculate the value of fx1 and fx2. If fx1 is greater than 0 or fx2 is less than 0, it means that, so if the graph of the function is like this, f of x1 is positive, it's like this, right? then there is something where f of x is less than 0. What does it mean? It means that function has a root. So that's given by IVP. If you go this and see, that is an intermediate value property if function is continuous. So in between the 2 points, the value of 2 points, you're gonna find a point where the function is 0. So it's like that. Yeah. So you have such points such that fc equals to 0. And c is between x1 and x2. Is that all right? So you're gonna get root at certain point of time. So how do you do that? So you have fx1, fx2 is less than 0. Then you're gonna check at x3. x3 is just x1 plus x2 by 2 that I already described. Just check the value of function at x3. So if it is greater than 0, or what can happen that fx3 can be less than 0, then in that case, just compare with the previous values. So I just use the red one. So if fx3 is greater than 0, just go to this. If fx3 is less than 0, just go to this. All right. And then merge your intervals, whatever. So you are merging your intervals. So your new interval become x1 and x3. Sorry, is it correct? x2 and x3, right? Just take x2. Where is that? Why is... Yes, so it becomes x2 and x3 and x1 and x3. So like this, whichever is that. So in that case, it is not and, it is basically or. All right. So that is to be seen. So if this is the interval, just go by this. You have a new kind of interval, just check again what is fx2 and fx3, and just create what is x4, which is just x2 plus x3 by 2. And then do the similar process until you reach the end. Okay. So I'm going to take a new page. Is it for new? Set a copy of the current page below. How to get a new page. Let's see how many people are coming. Let's enter them. Okay, where we are. Yes, so that's it. And you do the similar process until you reach like the difference between whatever your xn plus 1 and xn should be less than some kind of tolerance value like 10 to the power minus 5, whatever. So they are much closer to each other. And once they are closer, then you say that xn is the solution of fx equals 0. That's it. That's all done. So you have to solve a question like this. So I'm just going to write a question. Let me add some more pages. I don't know where to. Okay, this is that. Yes, all good. So let me write the question from here. You're going to use your bisection method to do that. So yeah, use bisection method to solve. So in this type of questions, you have to practice a lot, right? In the exams, they will ask like, it can be very complicated equation and you will find it hard to solve it. It may have many iterations. So you need to solve it like many times. You have to get an idea. If you don't get it, then you will find it a problematic kind of thing. So just solve as many questions as you can before your exams and just apply your methods. But this is the basic thing. So I'm just gonna write the question. Wait for that. Okay. Right. So Okay, so yes. So what's the question is just okay, so sorry, the question is this. Two. So you have an initial bracket of 1, 5, and you have an equation t to the power minus t equals to zero point 0.3. So solve this, find the value of find t such that this gonna be happen. Yes, using bisection method. So just do the same process, and in this case define your f and do that and tell me what is the value of t. And yes, so you have to do till second iteration. Yeah, just do that. I'm gonna see that, and let's do that in 5 to 7 minutes. Yeah. All right. So I'm just
Hello, sir.
Yes.
So still second iteration only you said, no?
Yes.
Still second, I mean, we have to find the root. I mean, it is moving towards 1. I mean, the initial interval is 1 to 5
Yeah.
given. So in second iteration, the value is, it's coming 2. Like the first is 3,
Hmm. Okay, let's
second,
try that bit.
second one is 2.
Is I just try first. Have to see. Wait a second. Can you see the screen? Yes. Okay. So what? How do you start with? So you're just gonna check value f at 1. What is your f, by the way, here?
So f is t e raised to minus t minus 0.3.
Ft is minus, yes. So this f is this, and then you
Yes,
have to check, and your
f of,
interval is 1 5, right? So what is f1?
so f1 is coming positive. It's
F1,
0.0679.
which is positive.
Yes, sir.
All right, so let's do that. And what about f5?
It's negative 0.266.
F5 is negative. All right, then you have to take what is x3, which is just 2, right?
Uh, uh, 2, how come, sir?
Oh, sorry, it's 3. Is it?
3, sir. 3, yes.
Yes. And what is
And now
f3?
it is negative.
So where it would be f1, f3, and you have to calculate at 2.
Yes, sir.
Okay. So it is like, what is x4 then? So you combine these things, is it? And x4 is just 1 plus 3 by 2, 4 by 2, which is 2.
2.
Yes. And what is f2?
And it is again negative.
Is it close to 0?
Yes, it is moving towards 1, sir. Actually, now f2 is again negative. So in the
Yeah,
next iteration, value would be 1.5,
1.5. Okay.
the root value.
So what I've said, you find t such that. Okay, so it's like, so t is basically 2, I say it, right? So till second iteration you get 2, but it will extend, right? So you go
Yes.
as many iterations and you will be close to 0. So you can try more iterations and check that until you reach the difference, like xn minus 1 is less than some tolerance minus 3, whatever. Yeah, just go till more iterations and you will find it. Okay, so I'm gonna explain you. Yes. Yes, Chandru, you want to ask something? Is it clear, everyone? Deepa, you wanna ask something or?
No, sir. Actually, now it is like the root actual root will get nearer to 1, and now in the next iteration our value becomes 1.75.
Actual
So
root
it
will
is,
change. I think so.
yes.
It
Now
should
it is
change.
because now the sign had started changing because till
Yeah.
third iteration we are getting negative values. Now the values have started becoming positive.
Oh, but I think so after some more iterations you will get close to 0. Is it?
Yes, sir.
Yes. Okay. But I said you have to do till second iteration. So that's the result. Anyways. Yeah. So in the question itself, in the exams, they will say just reach that this type of tolerance value and you are done. So it's like of, so if you have this kind of tolerance value, it's kind of limitation for your question limit. So it's kind of limit. So on n, like on which n you have to stop, right? Or they can describe your fxn should be less than some kind of tolerance. So that's a
Yes, sir.
limit on n. So these
Yes, sir.
type of inequalities, they say about the limit on how much you can reach until that time. Yeah. Is it clear? I think so. It should be easy. And I describe what is relative error. So the relative error is just, yes, so the relative error, and I give you one question on that. So relative error is just the difference between, it's kind of measuring the difference between the approximate and the exact solution. So you need to have the exact solution of the equation or a nearby approximate. So it's, the definition is x approx minus x actual divided by x actual. Is that? Yeah, so it's kind of how much far we are from actual solution, right? So there are kind of different types of differences. First is relative and other one is absolute difference as well. So absolute difference is just, absolute error is just the difference between approx and actual. That's it. So let's discuss a question on that. Okay. So I just write a question. So you have to find, yes. So if you have an equation like fx equals 0, and there are given like xl and xu are your, this is like an interval. You start with xl xu, which is kind of lower limit, and x4 is kind of upper limit, xu, sorry. Then you just go with, yeah, so what is the, at the end of the iteration, what will be the absolute relative approximation error? So if someone says you have to find the absolute relative approximation error, it's just the relative approximation error. And if someone says you have to find absolute error, don't don't calculate relative error, just calculate absolute error. Okay. All right. So I say you do absolute relative error at the end of iteration, at the end of first iteration. Okay. Yeah, so just calculate that. So in this case, I will say the actual root is, suppose your, yes. So the thing is here is the approximate, yeah. So here the actual is, x actual is just your, x actual is just the difference, and x real is just the, x approx is xu or xl. So just find using the formula that I described these things and find the relative error. So these are of course approximate values. They are not the exact, but after first iteration, this is the actual. So it's kind of hint. Just calculate the error and tell me what's that. Yeah. 2 minutes for this.
Hello, sir.
Yes,
So, for the previous problem only, we have to find error, or what exactly we have
let
to
me
do
go.
in this?
Which one is the first one or the second one? Here,
No, sir.
okay.
Actually, exactly what I couldn't understand the question, sir. Actually, what we have to do?
I just said you just use the formula for relative error that I've written here. You have to
But
yeah.
the function is the previous one, no? Like that e raised to minus t function.
No, 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 no. Here is f is the common function.
Fx equal to
Any
0 is
function.
the okay.
F is the any function because you are not using f right here. Before that you have used f, but here it's not.
Okay.
Yeah. So the relative error is just trying to say that just calculate the approx minus actual divided by actual and you will get. So actual you know and prox you know. So you can easily
Okay,
calculate that.
okay. Understood,
Yeah.
sir. Understood.
Yes, yes. If you are confused.
So here we have to find absolute error.
Here what did I say? No, relative error you have to find. Absolute
O-
relative error means relative error. If I say absolute error only, then absolute.
Okay.
Yeah. Just find it a bit and tell me if anyone has calculated a just yes. So if you have done this, so I just give a one more question on bisection method and you can just solve it in 10 minutes. So that's a bit more complicated and challenging. So let's try that one. I need to select a new page again. Yeah, so that's right. A bound for number of iterations needed needed I highlighted to achieve approximation with accuracy. So accuracy I described already. Accuracy means tolerance, so no confusion at this time. And to solution of 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 the equation x cube minus x minus 1 equals 0 lying in interval lying in 1 2 in bisection method. So I'm just gonna use the bisection method for that. So just find a bound. Bound means the upper value. For if you are having an iteration, just find this the box value, I'd say. And needed to achieve approximation with accuracy to the solution lying in 1 2. So start it and try to solve it. It's a bit different, but you will find it easier maybe. So let's take some time for that and Yeah, so and I will try to answer exact value of this. So I need an exact solution this time. I don't wanna just say it's done. All right. Yeah, so everyone has done this question, I think so. Right. So I just discuss with the book what is there. So in this book, I think this is described in your lecture notes, like you have to use this book. If I don't know. This is book by Graal and Wheatley, so you can just download it from the internet for free. Yes, so error after n iterations is just less than the absolute value of b minus a by 2 to the power n. So here is, sorry for the noise. Um, so here b is just 2 and a is 1. So just calculate b minus a by 2 to the power n less than your accuracy 10 to the power minus 5. And you know that. So I just use the blue color, not the black one, because it's, and you know that here b is 2. So yes. So it's just absolute is just the same as b minus a by 2 to the power n, which is 1 by 2 to the power n, which is less than 10 to the power minus 5. Because it's all positive, you don't care about anything, and just do that. What's that? 10 to the power 5. I just take it here, and then just take log on both sides. So it's just 5. If you can take any type of log, but it depends. So I just take log 10 10, log 10 2n, and then it is just, log a is just 1. So it's just 5 into 1 and log 10 2. And so n should be greater than 5 by log 10 2. And that's it. So n should be greater than equal to this number. You just try to find out what exactly is. I don't know if it is point something like 17.5. It may not be an integer, right? So just take your n to be 18, or just take your n to be greater than 18. But exactly you should take this because any value above it, any integer above it, same. Yes. Any questions? Deepa, you want to ask something?
Uh, here n is for the number of iterations, no sir?
Yes.
So like till 10th iteration, so we don't get that much accuracy. It's coming around
Yeah.
10 to the power minus 3.
Yeah.
The accuracies are like you can say like the you like a value of f at 10th root, 10th iterated root is 0.0062. So not very close to 0, and not even
Yeah.
close to 10 to the power minus 5. So till 10th
Yeah.
iteration that we don't get this.
Till 10th iteration, you wanna get this. But if you're gonna get like 18 or 19, I think you will get this accuracy.
Okay.
Yes, that means. So if just try to find out how this formula comes. Is it all right? I
Yes, sir.
haven't described like how this formula comes. Just try. Anyways, so let's start with the another method, which is called a second method. Where is that? Eh? Okay. Second. So second is more kind of upgradation to the previous method where you have kind of more complicated things a bit, but more simpler maybe. Very close to your exact root than the bisection.
Excuse
So
me, sir.
bisection may, yes, yes.
I mean, how? I mean, are we doing this? Like, I mean, we will do this in Matlab also. Is it like that?
Yeah,
How
you can
Matlab is going
implement any
to help
method in
us
Mat.
in? Yes, sir.
You can implement any method in MATLAB. I think in your lecture notes, in the YouTube videos you have provided with, they have given the codes in the MATLAB for these type of methods. You can just
Okay,
look
sir.
at that and try yourself. Don't look at just only, just try yourself for understanding. I hope so. Yeah, this is the problem with you guys, right? The MATLAB hasn't been provided access to you. I just email them once again to see what happens.
Yes, sir.
Yeah. So let's discuss second method then, if it's all right. Let's go there. All right, so let me read something over in the book. Second method begins by finding 2 points on the curve, hopefully near to the root we see. So you're just gonna start with the same 2 points, but not the random one like in the bisection method. Just try to guess the roots. Try to get the starting points near the root. And if your fx is truly linear, then straight line would intersect x-axis at root. That is a key point, right? So you don't need second method to apply that. So it's very simple. If fx is linear, linear means it's just a straight line. So you're gonna find that root easily. You don't need to do anything. But if your fx is not linear, then what you gonna do? You have to use some root finding method like the bisection one, but you can use second method. So let's see that why is important. So if you're if you not if you don't know the x, the root, so here see the picture. So you know only 2 points, you know only 1 point x naught, and you don't know the another point x. Okay, so just take x naught and x1 as starting points and just find out the value of function at these points, f of x naught and f of x1, like this says here. So you have to choose two values or given two values x naught and x1 that are closer to the root, not very far. Some disadvantage for that. And just check whether f of x naught is lesser than f of x1, the absolute values. So here f of x naught is bigger than f of x1, then in that case, if that happens, just swap the root. Swap x naught with x1 if that happens. So here you just swap. Here I think you don't need to swap because f of x1 is already less than f of x naught. So they have not swapped it. But in that case, you swap that and then repeat the same thing. So just set x2 equal x1 minus fx1. You know, this type of equation is just the equation of a straight line given 2 points. And yeah, so x naught x1, f of x naught, f of x1, and this is kind of slow. I'm not gonna describe how this come, basic maths. All right, so x naught equal x1, you set, and you find out what is x2, and then you just do the same thing like in bisection method until your f of x reach the specified value. So one thing that you want to see, the major difference between bisection and the second, is just the x2 value. In the bisection method, you have already seen the x2 is just the midway between your two guys, x1 and x naught, but it's not that case here. So x2 is just coming from this equation. You can clearly see that, right? So here, if I describe, so they came to this type of equation using the property of similar triangles. So x1 minus x2 by x1. So if I go here, then you look at the big triangle and the small triangle here and try to calculate, try to use the property of similarity between the two triangles. So similarity just means you just take x1 minus x2 difference and f of x1. So f of x1 is the amplitude here. So just gonna see that and just take this here for the big triangle same and just use that property to find your x2. So everything is same, everything same except finding what is x2. So if you are comfortable with bisection method, this method gonna work the same. Just try one question on this. Yes, so let's do that and just try that. And once you are done with that, let me know. Just take some time for 10 to 15 minutes for that. Okay, let me write the question first. Is it nice? You understood that? Deepa and others.
Sir, if you could just show that formula again, so that
All right. So
I'll write
let's
it down.
wait. Yeah. So I just give you a few minutes to capture this formula and then I will write the question. Is that fine? If that's fine, then okay. Let me mute my mic. Hi, so have you noted this? I hope so you have done this. So let's write the question on second method now. I just wanna use red one, my favorite. So second method, the bold for that, and the black one is for questions. So second method for finding the cube root. So if you have kind of x cube minus r equals to 0, use second method to find x. Use, I just say star, star to find x. Just try that. I think I used the another symbol. Anyways, just same symbol. You can't use x curly, x like this or something. They have different symbols. Don't do this. Just try for another 5 to 10 minutes, and I will discuss this answer. And we want to try more questions on second method. Yes.
Hello, sir.
Yes, Deepa. Yeah.
What is R here, sir? R any real number or what exactly
Where
it
is
is?
that? Yeah. So
R
R
is
is any real number. Yes. R is
so any
anything.
real number or in terms of R only we have to find it.
Yes. Yes.
So by taking R we have to solve it.
Yes.
No particular value of R.
No, no, no. R is anything. Any real
Okay, sir.
number. Just try. Just like the bisection method you have done so far. Similarly to that. Yeah.
Yes, sir.
Okay. And it keep try to find the general formula. Xn minus 1. Okay. Like the previous thing. That's the kind of generality. I just show you once what you want to do there. So here I've written this type of thing, xn plus 1 and xn. Just try to find the formula like here is like this, xn plus xn minus 1 by 2 in the bisection method. Similarly to this, you need to find. Yeah, I just go with, I just, I just go with the last slide. I don't know why this takes a lot of time to go in. Yes, just try to find a general expression. Yeah.
Hello, sir.
Yes.
How many iterations? Tolerance value is not given. No, here
You don't need to find the you don't need any iterations for that.
only one
Just try.
iteration is sufficient.
Yes, one iteration would
I
be
mean,
good.
I have obtained the value of x2 here.
What is that? All
It
right.
is x1 x naught square plus x naught x1 square plus r divided by x naught square plus x naught x1 plus x1 square.
Okay, let's try that. So what's the formula that I have described? Have you used that?
Uh, that x2, x0, x1 are assumed to be the values near the roots,
I
and
would say
x2.
um, this is the thing. So you start with any points, x naught and x1.
Yes,
Yes,
sir.
anyone? Chandru, you wanna ask something? No. All right. So just start with 2 points, x naught and x1, and find x2 using this type of formula. You know what is f of x here, and just generalize it. That's it. So that's not a very difficult question like this over here. So what you get, Deepa, is, can you tell me again? I just write here.
So the x2 value which I have obtained is x2 equals to
What is f of x? F of x is
f of x
x
is x
cubed.
cube minus r.
Yes. What is x2? x2 is
x2
x1 minus fx1, right? And
times
x naught minus x1 divided by f of x naught minus f of x1. So what is f of x1 here?
it is x1 cube
So
minus r.
yes. So x1 cube minus r, x naught minus x1. F of x naught is just x naught cube minus r. And what's that? x1 cube.
Minus r.
Yes, and then you can cancel out r, and
Yes.
you just cancel out x0 minus x1 from these two. So it's quite calculative. Who's just gonna do this? X naught minus x1 and 1 plus x naught. What's the formula you use for that? A square plus
So,
b square
so
plus ab. Is it?
no, so it is a cube minus b cube formula we will use, which is
Yes.
a minus b times a square plus ab plus
Yes.
b square.
Yes. That's I know already.
So that x naught minus x1 term gets cancelled from numerator and denominator.
Yeah, so just solve it and you and replace your values like 2
Yes.
by n and 1 by n minus 1 and 0 by n minus 2, and n is greater than or equal to 2. That's what I said. Is that all right? So that's kind of
Um,
using this, remembering this formula. I have given this question for you.
okay.
Yes. So you need to remember this formula. That's why. Yes, anyone? Is
So
it
we have
clear?
to yes.
Okay. Yes, Deepa, you want to ask?
I mean, we have to generalize this formula only, this expression only.
Yeah, that's what I said.
Okay, okay, yes, sir.
Okay. So let's go on. Let me write one another question. So you are very good in remembering this formula now. So I just write another question for you guys. Let me see which question would be good. And let me try that. Okay. Where is that? Okay. It's kind of didn't find any question on second method. So I would say just try with the same question like t to the power minus t and try to calculate up to second iteration what you're gonna get. So I will give you this again. So apply, I will ask like which value would be good. So, and yes, wait. So instead of using bisection, just try second to get a feel. And let's discuss what is the second value. Here it was 1.5, but with the second method, what's the second value? Just try that. It's a bit kind of complicated, but just try. With starting values 1 and 5. Yes. So I hope you have tried this question. Why people are joining at this time or they are leaving? I will have to create a function to admit everyone later on. Yes. So in this, what the value you got using the second method? Anyone? Can we
Sir,
try?
it's 1.766 in the second iteration.
All right. Did everyone get the same thing? Oh, here, so
Yes, sir,
it's
more or
close.
less same.
This is the value of f of 2. Okay, that's good.
So by
So you tried,
bisection method,
yes.
also it was coming around 1.75.
Mm-hmm.
So this time also it is somewhat same. Like,
Somewhat same in the means what's the
I
difference?
mean, in this range only the value is coming
Yeah.
1.79. I have 78. Sorry.
Okay.
I got as 1.766.
1.766. All right. So there may be some I think second method is more accurate than bisection. Yes.
Okay, sir.
Yeah. So I would say if you have any doubts regarding this question, just ask, and I move to another question, which is called another method, Newton method, which is nice, which is very useful method. Everyone uses that for faster convergence. Yes, is it clear, everyone? Second method. If yes,
Yes, sir.
let's go to Newton's. So what's the difference between the second and Newton? Okay. Yes, so here in the second method, you have to make sure to always start with x1, which is closer to the root than x dot, by testing fx naught and fx1 and swapping. So this is kind of thing you have to make sure before using. So what's this disadvantage? Let me try to see that. Okay, there is another method than Newton's method. Um, okay, so what's the difference between both of them? So in the second method, you are using kind of similarity between the two triangles, but here it's not the case. You are trying to start with x naught, so it's kind of more flexible in terms of choosing the 2 points, because in the earlier methods you always start with 2 points, which is not always easy, right? So starting with 2 points, you need to have 2 points beforehand, and it's not easy to always have 2 points which are closer to the root. So you have to start with just 1 point, which is kind of x naught, and you try to calculate the value of f at x naught. You have to, and using x naught and fx naught, since fx naught lie on the curve of the function you are dealing with, so just go in that direction and end up in getting an intersection with the x-axis, and just try to see x1. So next point is coming from your function. So next point is coming by solving this equation, f prime x naught, which is kind of derivative of f at x naught, the angle which it makes with x-axis, and which is just like fx naught divided by x naught minus x1, using the tangent property that you say. So it's like tan theta. You can always write like this. So tan of theta, tangent of theta is just fx naught divided by x naught minus x1. So all good. You got the value of x1 from here. X1 is x naught minus fx naught divided by prime x naught. So what's the difference between the two methods is this thing. So f prime x naught is kind of approximation in your earlier method. If I go there, where is that? So in the second method, if you see clearly that f prime x naught is covering this whole part, right? F of f prime xn is covering this whole part. So um, you are just putting this big chunk of part, and you are just replacing it by f prime x naught. So here it's just more faster, more simpler in that case. And yeah, you can always use the approximation of your f prime if you don't know the derivative. But in most of the cases, you always been provided with a continuous function or derivable function, that's always easy to find the derivative of. So xn plus 1 is just xn minus fxn divided by prime xn. So just replacing that part, and you just try to calculate the x1, x2, x3. Very simple, very easy. You just have to start with some point, and similarly, yeah. So if possible, can you try to find out the same thing with Newton's method? Right. Let me go on this. So just try this using now Newton's method and let me know what you notice the difference. Just try, and I will try to solve it as well with you this time. Just take some minutes to do that. Hi, so I hope you have already done this question. So let's go with the method. Where is, all right, t e to the power. What's the question is t to the power minus t equal zero point 0.3 and 1, 5. Okay, so here is the, yes, so t e to the power minus 3 minus t minus zero point 0.3 equals to 0. It is your ft, and f prime t you have to calculate. So first step, try calculating f prime t. So that is the derivative of ft, which is just, what's the derivative is power minus t plus minus e to the power minus t, and yeah, so zero point 0.3 derivative is just 0. I think you get the same. Is that clear? The derivative, and just use the formula. So what is t naught here? It's just 1. If you start with 1, then you get f prime 1, which is,
So it's, so f1
which,
will be dash
oh,
1 becomes 0, sir.
this is different. What are you saying?
Sir, so actually, if we start with 1, so
Yeah,
our f prime value becomes 0 and it will go in the
yes,
denominator. So that's why
yeah.
we
We have
should
to start
select
with such a point such that f prime at that
is
point should not be
non-zero.
zero. Yes. All right. That is a good point. So you need to start with something like that. So let's take f prime 2 if that's true. So in that case, you have e to the power minus 2 e to the power minus 2, which is just minus e to the power. Okay. So what is f? What is t1? T1 is t naught minus f t naught f prime t naught. Is that all right? Yes. So t naught is just 2 f. What is f t naught? It's not that same. Yes. So just put the value of f at 2, which is just 2 e to the power minus 2 minus zero point 0.3. I think I just done with plus. Okay. Okay. So it is your t1. And just this is your t1, like the same thing, you just try to calculate what is, you have two conditions. ft1 should be less than something, means some kind of accuracy, or you just check this type of thing, or you just check this type of thing, t note, any of these, and then you are done. So you just find out. Is this clear, everyone? Yes. who is who is asking? Yeah, so I'm done with these three important methods for that. And if you have any questions, just ask now. Yes, everyone. Deepa, is it clear? Others?
Uh, yes, sir. Actually, this time the root is, let me, the value of root at third iteration is
Yeah,
1.781. It's coming.
means it's more closer, I think so.
Yes, yes, compared to other previous two methods.
Mm,
I mean, here the accuracy level is 10 to the power minus 5, 10 to the power minus 5.
means you can, it's specified in whatever, in the question, like what accuracy you want to need.
Because
But
I
if you
started
go
with,
for three iterations, if you do three iterations for all the methods, I think Newton method will give the closest thing.
yes, sir, because its rate of convergence is 2. So
Yeah.
actually here it depends, like I started with 1.5, So now
Yes.
it is like every time the value is around 1.78 only.
Okay. Okay. Means much closer to root. Yeah. But you
Yes, sir.
always don't know na which value will be closer to root.
Yes,
So
so
yeah.
because here we took the reference of previous two method, that's why I could guess that
Yeah.
method to start with 1.5.
Yes. So you may have certain type of idea before, yeah, choosing the
Yes.
value, but it's always not the case.
Sir, I'm getting around 10 power minus 6 as the accuracy in the second, third iteration from Newton-Raphson method.
10 to the power minus 6. Oh,
Minus
nice.
6, yeah.
Yeah. So Newton method is very fast and has high rate of. So if you have the book by Gerald and Wheatley, just follow
Sir.
that book, and there is a proof of convergence for Newton's method and other methods. You may find it easy to understand, I think, and this is interesting to see.
Okay, okay, sir.
That, yeah. So other than Sushan and Deepa, anybody has other questions for this type of methods? Geeta, Nasir, Rakshita, Sanjana, Sashmita, others. Right.
Hello,
So
sir.
if you
Good evening.
don't have, yeah, yeah,
Hello.
yeah. Nasir, yeah.
Sir, I
Yes,
just have two queries.
yeah,
I have just two queries, sir.
yes.
Uh, so when we had this video recorded of week 3, sir was
Yeah,
also talking, professor was also talking about order of convergence. And
okay.
in the computation by using Matlab, he also shows, no, whichever the problem he took, he also showed the numerical convergence. So
Hmm.
there, Newton-Raphson method, again we got two. Okay, and there's some problem where the convergence was lesser than what it is. So he said it will never cross
Yes.
the convergence. So my question is whether numerical, I'm talking about numerical convergence. Okay, now for
Hmm.
example, Newton-Raphson convergence is 2. But when we come to numerical convergence, is it now
Okay.
if I take any a particular, let us suppose, non-linear equation, and
Yes.
if I take some initial value, so my
Yeah.
question is whether the numerical convergence will remain constant irrespective of initial guess, or it is going to
No,
vary.
there is, yes, for numerical convergence, the graph should be, so there is kind of log plot. So if you do in MATLAB log plot, it's just the difference between your exact and numerical solution. Just try to plot that. The graph will should be parallel to the line of order h square.
So my worry is whether the
Yeah.
convergence, numerical convergence, will depend on the initial guess, or it will be independent of initial guess.
I think it should be independent.
Because I just took one example, where the rate of
Yeah.
convergence of what Sir has taken
It should
example.
be independent, but you may need to do more iterations to achieve the convergence rate.
Okay, but what I found when Sir was taking one problem, no, so he got
Yeah.
again rate of convergence of Newton to be 2, whereas the other
So
method,
let's
whichever was there, it was less than the usual convergence. So one
so
I
if
took
you
very near to the root,
yeah.
so the rate of convergence was 1 for Newton-Raphson
Hmm.
numerical convergence. So that's what no,
Okay.
there I have a doubt.
Let's see the proof where they started with. If they started with, I think, very close to root, then order of convergence. So if you go with Newton method, oh, that's another thing. Yes. So convergence of Newton's method. They start with that resembles Newton method use iterations that resemble fixed point. I don't think so. They start with any random number, but but technically you need to be in neighborhood of the root if you want to achieve this convergence. Yes.
And so one
Don't
more
start with
request.
very far. Yeah. Yeah.
So one more request, whichever the
Yes.
reference book it's been suggested or recommended by professors, we are not able to get. So can you just please, whichever the book they have recommended, and even you are saying
Oh,
some two books, can it be uploaded in the link of the portal so that we can download and go through that? It will be still more helpful for
yes.
us.
All right. It would be interesting. I would do that.
Yeah,
Yeah.
please. No, because in the
Which
link,
books you want?
the portal,
Whichever I'm using, or the professors have
yeah,
provided
the one
us.
which both, sir, both. That will be really good for us. Because
Okay, I
as
know
we
that.
get at least two to
Yeah.
three textbooks,
I
no,
do have two
referring it will
books,
be,
Amkiran and this Kiral and Wheatley. I will upload them. Yes.
yeah, please, yeah. And even what professor also says that also if we are able to get to using MATLAB,
Yeah.
no, it will be great help, sir.
Hmm. Hmm.
And so the last
All
question.
right.
So coming to our
Yes.
exam, now we were trying to do manually. So are we getting now, for example, the assignment problem which we are getting, some problems we have got so many iterations. So are we going to get the access of MATLAB also in the examination, or we are going to
No, no, no. You
just
won't get access. You won't get access to MATLAB.
so it means it will be a less amount of calculation type.
There will be very basic questions on MATLAB that I've already said.
Okay.
So no, not much is
And
needed.
even the calculation, okay, even the calculation whichever we have got, it will be like
Yeah.
one or two iteration like that. Okay, fine.
Yes,
Thank you.
yes. It can be up to 3 maximum, not more than that.
Okay, thank you. But kindly upload this material. It will be great help. Thank you.
Yes, yes. Sure. And please attend if you have time tomorrow at 2. I wanna see some people. Otherwise it would be boring for me. Tomorrow at 2. Just remember. All right. All right, everyone. So if you don't have any more questions, then I just close this and let's meet tomorrow.
Thank you.
Thanks. Thanks.